Right, so we're going to be talking about factoring polynomials. Pretty much what you're going to be doing is you're going to be unmultiplying. And it sounds hard, but it's really not. This is not dividing. If some of you are thinking that, we're going to be using our prime factorization, or GCFs, for this. But before we even do that, you're going to need to know what both of these things mean. What does GCF mean? You've got greatest common factor. This is something you learned way back when, and you probably have cobwebs on it, but you're going to be using this again. It's pretty much the largest factor we can divide two or more terms by, which means we're not going to be working with just numbers. We're also going to be using letters, and we might even have to expand until we understand. And the other thing that we're going to need is prime factorization. Even though you use it, you don't really remember what it's called until we see a picture of it and you're like, oh yeah, I know that thing. And that's pretty much you're going to break a number or term down to only its prime factors. Pretty much what we were doing and what is similar to when we work with radicals. You split it to its factors and you keep going, and these are prime numbers, and that's where they stop. We're going to go ahead and find the prime factorization and the GCF of the pairs of the numbers that you see on your notes today. The first example that we have is 8x and 24. We're going to take it one term at a time, and I've split 8x into 8 times x. We know that x can't be split anymore, so we're going to put a circle on it to remind us that it stopped. If you want to do this with different colors on your notes or your assignment to kind of help you, you're more than welcome to do so. This is just to kind of get you started and jog your memory a little bit. 8, however, is not a prime factor. You still have a couple of factors from it, and you can multiply to get 8. I ended up picking 4 and 2. I know that 2 ends up stopping as it's a prime number, but 4 will split one more time into 2 and 2 because 2 times 2 is 4. So we put circles around those as well because they're prime numbers. At this point, I can't split anything else. All of these branches have stopped. So we're going to go ahead and factorize to our prime numbers on 24. For 24, I picked 8 and 3. You can pick 6 and 4, 2 and 12, 12 and 2, 4 and 6, 3 and 8. At the end of the day, your prime factorization is going to be the exact same. 3 is a prime number, so we're going to go ahead and circle that one. However, 8 is not a prime number, and we're going to go ahead and split it up. Lucky for us, we kind of already did it, so it'll go a little bit faster for us. We know 2 is prime. 4 does not. 4 is still a composite number, not prime. So we're going to split that into 2 and 2. Those are both prime, and we're going to circle them. Now your GCF is going to be these right here. They're going to be the numbers the factors right here. And sometimes even the variables that are the same on both factorizations. So you've got a heart of 2s. You've got 1, 2. And you've got a couple more here. And then x and 3 are not the same thing, no matter how we write them. So our GCF right here would be 2 times 2 times 2, which gets you 8. And in this case, your GCF would be 8. Now, some of you might have already seen that because you know 8 times x is 8x. And you know that 8 times 3 is 24. So sometimes you won't even need to take it down to its prime factorization. You'll already see it. Like I said, this is to help you kind of break it down and see what's happening. So let's go ahead and do it with example 2, where we've even got an exponent on our variables. I'm going to go ahead and do 27y squared first, which is 27 times y squared. Now, neither of these are prime because I can expand y squared because I know that this exponent tells me I'm multiplying y by itself that many times. So I'm going to go ahead and write and split both of these, again, since they're both composite. Now, y times y gets you y squared. Y is prime, and your other y is prime as well. I put my stoppers on them so I know I can't break these down anymore, and I'm done with that branch, with both of them. For 27, I picked 9 and 3. You could do 3 and 9. 1 and 27, you don't want to do something like that because that's just using its prime numbers, and you're going to be stuck in an endless loop if you're writing that number over and over and over again. 3 is a prime number here, so we're going to go ahead and circle that off. 9, however, is not. 9 is composite. So we're going to split 9 up, and 3 times 3 gets you 9. 3, both of the 3's are prime numbers. Circle them up. All of your branches are closed, so we're going to go ahead and go to the next one. Now this one is going to be a little bit different. You already know that it's going to split up into negative 18 and y. But something else you want to do whenever you have a negative number is split it up as negative 1 times 18. And that way you can get rid of that negative right there and just work with your number as you are used to. And you'll notice that while we were talking about this, we also circled off that branch because we knew it was y is this prime and we're not going to be furthering it. And in the same situation here, negative 1 is prime, so we stop that branch. Again, it's to get our negative out of there, and that way we can factor like normal with just positive nice numbers. 18, I went ahead and split it up with 6 and 3. You could have done 2 and 9 or 9 and 2 or 3 and 6. Again, your prime factorization will always end up being the same. These stoppers, your prime factorizations, will always end up being the same no matter if you do 3 times 6 or 2 times 9. 3 is a prime number, we're going to circle it off. 6 is composite, which means we're going to split it, which is 2 times 3, or 3 times 2, however you want to write it. Those are both prime numbers, so we're going to circle them up. In this case, we're going to go and look at our GCF, and we're going to look at the numbers and possibly even letters that they have in common. We know that they have a 3 in common, and this one you have to look for it because it's not in the same order, but you've got 3's. So far I've got 3 times 3, but we've also seen that we have a y in common, and that's good. We want to take variables out, and you're going to start doing that as part of your GCFs. So you've got 3 times y. 3 times 3 gets you 9, and now you've got 9y. That there is your GCF, and there's nothing to it. There's nothing further to it. We're going to take this one step further now. We've split it up, and this has kind of gotten us ready for our actual factoring of polynomials using GCF. We're going to go back, and you'll notice the example has stayed the same. All I've done is I've put in an operator there. I've put in a plus sign or a minus sign when we get to example 4. We already know the prime factorization, the GCF of 8x and 24. So I went ahead and wrote that down. Now when you're doing your factors, you actually write that GCF first, and you're going to put parentheses for the next stuff that you're going to write in there. This stuff right here tells us what we multiplied 8 by to get 8x and 8 by to get 24. If you need to look back at example 1, it is here, and it's also in your notes that you're taking along with us, of course. If I didn't know that 8 times x gave me 8x, then I could look back at my factor tree right here, and you'll notice that x is the only one that's on the 8x side without a heart. So we're going to go ahead and we would write that in. Same thing happens here with the 24. 3 is the only one without a heart on it, and you write it in. You'll notice this is now a number. It's some factor times a binomial. If I were to write this out and check if this is actually going to get me 8x plus 24, I would get it. But you don't want to keep doing that. You're going to get stuck in a loop. Your factors are just that. You're essentially creating the problem or the expression that we would give you for you to go ahead and distribute out. We're going to go ahead and try it with example 4. Again, same thing as the second example, and our GCF from that was 9y. When we're looking for our factors, we're going to put 9y on the outside, set up our parentheses. And then remember, on example 2, we had a couple of different factors that weren't so great. Now, you'll notice I did it as negative 18y, and that's because we had a minus sign in the middle. Right here, 9y times what gets you 27y squared? Well, you've got 9 times 3 gets you 27, and y times y, that gets you y squared. Similarly, while you're writing that one, you just have a 2 here without a heart on the negative 18y side. You've got 9y times 3y minus 2, and those would be your factors. You would put a box around that and you would be done. Remember, you're creating the problem. We've given you the answer that you have been creating up until this point, but now you're working backwards and you're able to tell us what the original question was. We use this process always. We always are factoring by GCF, but as you saw just a second ago, we're going to be factoring by grouping. Essentially, you're factoring with your GCF with 2 different moments. This one, for example 5, I'm going to go ahead and split them up. These are different numbers that we're going to be working with, and you only want to be working in terms of 2 terms at a time. So with x squared, when I break it down, it's just x times x. With 4x, it splits up into 2 times 2 times x. Common thing that they have here, their GCF is an x, and that's it. So I'm going to write it out on the side, and you'll notice that I've gone ahead and put in my factors here. Because x times x and x times 4 got you these 2 terms. I'm going to keep my GCF out to the side because I still have 2 more terms to work with. And you're going to see something interesting happen. 2x splits up to 2 and x, and then 8 splits up into 2, 2, and 2. Only common thing they have is a positive 2. And you'll notice I've put that positive 2 in there. 2 times x gets you 2x. 2 times 4 gets you 8. Notice both of these binomials right here, by the way, they're the exact same. And that's what you want when you're factoring by grouping. Now, we need 2 binomials for this because we know we have a quadratic here. And we have a polynomial of the 2nd degree. So I'm going to take my GCFs and make it one binomial. And now we're going to copy down the one that we had that was the same. In this case, these would be your factors. And you would put a box around your answer. If you were to FOIL, box, or vertical this, you would end up getting x squared plus 4x plus 2x plus 8, which of course simplifies into x squared plus 6x plus 8. All right, so let's go ahead and try the second problem right here, and this is going to be our last one. We're going to be doing grouping again, so you're only working with these 2 first, and then you're going to work your way up. So I'm going to look at the prime factorization of 4b squared, which is 2 times 2 and b times b. And then this one, remember, in our last slide, we took out the -1, so it's going to be -1 times 2 times 2 times 3 times the b. And if you need to do your factor tree on the side to kind of see where this is coming from, you're more than welcome to. And like I told you guys on the last slide, you're going to start seeing some of these a lot more, and that you won't even have to do the tree. So right here, we're going to go ahead and circle our common factors. We've got a 2, we've got a second 2, and we've also got a b. So I'm going to go ahead and grab that out. And that gives me 4b because 2 times 2 is 4, and then times b is just 4b. Go ahead and write my parentheses, and you'll notice that b and -3, b minus 3, are the only things that are left on each of these terms. And because 4b times b gets you 4b squared, whereas 4b times -3 gets you -12b. You know the other one is going to be b minus 3 here, but just in case, we're going to pretend we didn't know, and we have to double check our work. So I'm going to list out my prime factorization for both of these terms as well. 2 times b, -1 times 2 times 3. Only thing common they have is a 2, and it's a positive 2 that they have in common, so we're going to put plus 2. If they both had a -1 in common as well, that's when we would write minus 2 here. 2 times what gets you b? I'm sorry, 2b is b. And then 2 times what gets you -6 is a -3. And you'll notice that this binomial is, of course, the same, which means we have factored by grouping correctly in this one. These first two GCFs, this GCF and the second GCF, we're going to write them together as a binomial. And then we take the other factor, our other second binomial, and write it there. These are our two factors that if we wanted to double check our answer and we were going to FOIL this out or box it or vertical it, we would end up getting these 4 terms, which would of course simplify here. But at this point, you would box your answer, and that's how you would leave it. Remember, you're trying to find the problem that gave you this answer, not the other way around. You're not looking for the answers anymore. Your answer is here. The answer to the question is here. I want you to tell me what was the problem that got you that answer. If you need to, go ahead and watch this and kind of pause it wherever you need to. You have an assignment over this that you've gotten in class. Please be sure that you get that in, and it's also posted on Google Classroom. Oh, and just for Angel, here's this picture.